I'm gonna. So we're live. We're recording. I'll throw it up on Twitter. I will have cut out the long discussion on coronavirus, but otherwise, yeah, this is Coffee Compiler Club. I have my coffee. We're talking compilers and languages and whatever people want. I reserved the right to moderate. Never had to do it. Open mic. I think everyone's here an old timer pretty much. So the only thing that I have as an opener, and we can totally, take this conversation in a different direction, is that over the last couple of days, there was a conversation from on Twitter feed from Alexi and a bunch of other folks about the Java memory model ordering. And there's some crazy things going on in the memory model ordering that are entirely non-obvious, that actually work correctly in the model and do weird things on x86 even with its super conservativeness, and definitely on ARM and Power. I got asked a question, does C2 ever remove volatile barriers? If you have a dead volatile variable and you write to it or you read from it, does C2 remove the barrier? And the answer is no. But it can remove the read or write if it's dead, but it won't remove the barrier. There are very limited circumstances where C2 removes barriers. That being said, the Java memory model allows you to be more aggressive. And certainly when I was at Azul, I got more aggressive about the memory barrier removal thing, which led to discovering people's broken Java code that was broken by the Java memory model and happened to work on C2 on x86 and did not happen to work on Azul. It was very frustrating time.
Good to double check locking works well.
Yeah, that one was, that one's been known busted for a long time. Everyone here know what that one is? This is a good opener question. Double check locking, and you know why it's busted.
Yeah.
I don't think it's fair to say that it's busted, right? There's just the wrong way to do it.
Well, the wrong way is busted. That is to say, the wrong way will get you strange, unobvious results that are clearly not what you want. It'll give you uninitialized singleton contents. And the fix is put a volatile in, right? So the all sorts of fun variations thereof do not work.
Even the Josh Block suggestion?
Throw it on the chat, because I don't know what the Josh Block one is off the top of my head.
Yeah.
There's a handful of ways to do it correct. You put volatile on the publishing variable, not on the lock itself doesn't save you. The lock saves you only from doing the initialization twice. But if you don't volatile the variable that you're publishing, you can still get the contents of the body out of order from the publish because the reader is not synchronized.
I've always taken the tack that this is a, doctor, it hurts when I do that moment.
Right. So there's been a lot of people screw around here because under some circumstances, these things can be hideously expensive when they're correct. And so they're trying to cut corners. If I have 1 million people reaching for a singleton because it's the database connection or whatever the hell it is, it's the network connection for my high frequency trading, whatever. And there's a singleton and they grab a lock, it sucks by factors of 30x to take a lock.
Yeah.
So they do it without a lock, and then it gets tricky.
Maybe you can answer this question for me. Why does Java, whenever it allocates an object, doesn't allocate into a temporary and then assign the variable? Why does it assign the variable and then calls the constructor on the variable?
It doesn't. It follows the program order, and then the compiler does what the compiler does up to the limits of the Java memory model. So when you say new as a bytecode, the bytecode semantics in order in the interpreter at that time push onto the interpreter stack the allocated object with all zeros. Then it calls the constructor inside out to begin filling in the fields. If during the call inside the constructor and the nested constructors, you publish the object, then you skip all possible memory ordering guarantees, including final fields. if after the object's been filled, you then publish the object, the rights that fill into over the zeros and the right of the publishing store are unordered unless you have thrown down a specific order. And because they are unordered, the compiler is allowed to reorder them and the hardware is allowed to reorder them.
So it's because there's no memory barrier at the end of the constructor. Then
Of the nested series of constructors, at any one layer of which you might imagine you want a memory barrier or not. If you put a final field anywhere in there, then you get a barrier at the end of the whole construction tower. One barrier at the end of the whole construction tower, which even on x86 has to do something. It's an ordering barrier on x86. It doesn't actually put an op. I don't believe that one puts an op out. There are ops put out in funny places on x86. It's still not conservative enough. But on ARM or on Power Azul, you had to have an op there. Forced to order.
Flush of some sort?
I'm sorry?
A flush or what?
Yeah, right. It was basically a store ordering. You demanded that all prior stores be complete before the current value could be stored. The published object, the object not published yet. At the end of the constructor, no one can see the object unless you publish it. Before the next publishing write happens, you have to have a memory barrier down that forces all prior stores to be complete. The obvious thing the compiler does, because he doesn't know when the next publishing write happens, because that happens whatever he does with inlining of layers and layers, and if he runs out of his compilation scope, the next publishing write might happen outside of his compilation scope. So before he exits compilation scope or publishing write, he throws down a memory barrier. And in particular, it's a store barrier, which on an x86 is a no-op, but it's a line in the sand. And so if he has a write which may publish, he's not clear, and he has a final field in the object, he will refuse to reorder the final field all the rights in the object with the rights outside of the object constructor.
That's an implementation detail though, right? The memory model guarantees around final fields aren't as nice as what you described.
No, they are. I described how nice they are, which is all rights in the object are, you get a final, well, there's a word for it, final publish or something. You have a term for it in the memory model. I'm pretty certain.
Right, but I thought in the memory model, all the fields have to be final in order for that to kind of do that cheat where you can publish an object in a dirty manner and have it be safe. But it sounds like your implementation in C2, as long as you had a single final field, you would be safe.
I'm thinking the model says if you have a single final field, all the rights are done in the model, not under C2. C2 also, but in the model it says. I believe that is the case. I don't know.
Check. That would be much nicer to be able to rely on.
It might be that the guarantee is only for the final fields, but C2 and I guess other implementations do this for all fields just because it's easier just to put a barrier.
Right, you have to have a barrier for the final. You might as well roll it up and do the barrier for all the finals.
Yeah.
But then there's no point in having, at this point the cost is much, there's a very much a pragmatic thing there where it's very cheap to get them all if you're going to get any. This leads to an unexpectedly high cost for auto-boxing, which in addition to guaranteeing you a cache line miss because you just did an allocation, you can't reorder the rights to fill in the auto box primitive with anything that follows because it's a final field. So auto boxing primitives have sort of a double hit for their expense. It's a lot higher than it looks.
So a very much related thing, when you assign a volatile in a constructor,
yeah,
I'm curious, I believe the C2 implementation, it pays the full cost of the volatile, right? But I don't think the memory model requires that. So I've seen like it's cheaper if I have volatile fields to leave them uninitialized, let them have null or zero, than to actually initialize them to some non-zero value. On x86 C2.
Because the volatile rights on an x86 are just an ordering. They do know, again, they do no actual hardware op. They just refuse to order. So if you have a volatile field and you are initializing it to a non-zero value, it doesn't matter constructor or not. There's nothing related to the constructor here. It's just going to
do the
right.
There's no there's no optimization of that, avoiding the cost of that volatile, right? So an
And
uninitialized volatile is
okay,
cheaper than a initialized volatile.
So right, there's no an uninitialized volatile got freely set to 0 by some bulk zeroing thing that is being done to initialize objects. So objects go through 2 layers of initialization, right? There's a zeroing from raw memory, and then there's whatever you do in the constructor. And the zeroing shall not ever escape, even if published early. So there's usually a fencing operation done once after the object's filled with zeros. Now, that can be done in bulk, in 4K or 8K chunks, well ahead of time. It can be done page at a time by the OS. It can be done incrementally, line by line, whatever. There's a lot of ways to do, skin that cat, but there's one round there. And your volatile fell into that bucket, which is bulk 0, and so it's cheap. If you then do another volatile write, you have an ordering barrier. The write is the cost of an x86 write, pretty cheap. But the ordering barrier may prevent further optimization. And the ordering barrier carries on for, it crosses, things can't flow around the ordering barrier. That's what's going on.
So if
I'm reading the chat here, which I was just reading. Let me post a link here. He's got a good write-up here. Let me actually get the base. I say Shippolev. So Andrew, he's not here, but he's a good guy. It's a great write-up, and he has a conversation about finals where he says something a little different. But you might be right. It might have been saying.
It's definitely, the Shiplow stuff is the source of my information. So if what I'm saying disagrees with that, then I just got confused.
No, it's fine. No, I had to beat my head around it a long time ago, and kind of came up with the Roach Motel as a decent model to live with and code by. But it's more conservative than what the model allows. But I didn't know how to do the model under sort of generic compiler optimizations, where I could do the Roach Motel model.
Yeah, constructors are definitely one of the undesigned parts of most object-oriented languages. It's kind of like they left it for last and then never got to it.
Well, right. They started with, finals, as everyone wanted to const like C++, but then it became multi-threaded and you had to have a memory model. Until like 4 or 5 PhD theses, hit the table and got completed, we didn't understand what it meant to have a model and what your choices were. And that's sort of where the Java memory model came around from. Certainly at the time I was implementing it, I was doing something that was conservatively agreed to be reasonably correct by all parties involved, but we also had all these funny corner cases that we were sorting out. What does it mean? And finals came around late in the party as a way that you could slip things through. In particular, strings had final fields, the array pointer, and you could screw up with a string and break security if you could do a race and write to a final as part of the constructor somewhere. And that turned into a security issue. So then there was a go around again with the memory model and finals, and that came on. So finals had a little bit of a wart add-on at the end. Yeah, so the conversation here says something a little more loose than what C2 implements for final fields. And then Chaim's asking, does double check walking work? If the field is final, no, you can't write it. You can't have both final and volatile. So if you write it as a final, somebody has to fill it before you, so that blows the purpose of double check locking. So the way to do it that way with double check locking is you have to wrap the guy in another inner class so that it's constructed lazily. So you're looking for a lazy construction of a final field. Well, final fields can't be lazy. So you have to put it in a nested class. You can make it lazy. As soon as you put it in a nested class, the class wrapper, the class loader locks for you. And you get like official properties.
I suspect he means if your containing class has a volatile, and the thing that it's going to reference with that volatile has only final fields. Is that?
Oh, okay. So I thought you were talking about the publishing guy. If instead you have an object with only final fields, you're okay. Also, you still have to do the lock to avoid double construction. But if the object that got constructed has only final fields at the exit of the constructor, you are guaranteed to see all those things. And then you publish. And the ordering between the rights to the contents and the right of the publish is guaranteed by final.
By the way, going back a question, I think someone asked about Josh blocks right up in effective Java. I think it's all, to the best of my knowledge, correct. And
yeah, I just don't know which one, what Josh blocks thing is, because I don't have it like.
Yeah, it's just basically you need to use a volatile
Okay.
for double check locking. So it's pretty standard stuff. And then he covers the fact that you can safely publish objects with only final fields.
Right. Okay.
With less ceremony.
Yeah, I'd say no, more ceremony, because if you add another field that's not final because you're doing maintenance, you lose. Whereas if you have a volatile right, a volatile field for the singleton, and a big ass comment that says, "And here there shall be a volatile, or else you're busted," I think you're much better maintenance wise. You just acknowledge the dragon and defeat it on the spot, as opposed to, yeah, we're all good as long as you use finals. But if you slip another one in and it's not final, it's not good. I mean, that's.
So that the reason you would do that, right, is, I mean, who cares about the volatile, right? In that case, you're trying to save the infinite number of volatile reads that come along afterwards.
Yeah.
And to go back to last week's conversation, right? So on x86, the volatile read is free or very close to free, but on ARM, it's not the case, right?
Right.
So in the future, we may worry more about those volatile reads.
Yeah, Shipwell includes a bunch of performance numbers for half a dozen right and wrong way to do that on the safe publication, safe initialization, which you can find the link in there on ARM. And the main one is, thou shalt never grab a lock under the standard get or you're dead. Otherwise, the cheapest one is you use an extra class, because the extra class does the locking one time during construction of the class init. And after that, it is a free write. Yeah, final wrap.
It's just that's restricted to singletons, though.
Yeah, it's the singleton class. Right. Well, this is double check locking, which is the point of it is you only initialize something once. I see. If you have a collection that you're pulling out of like a hash table.
There's things like the getting the entry set off a hash map, right? You might want to avoid constructing that entry set, but you can't do that with a singleton pattern, right?
Yeah.
So you're left with double check locking.
Yeah. Fine. Yeah.
With the thing about this cost, actually having to go through this code all the time, it's like, it's really, you can design yourself into this box, and it's just but in my opinion, it's just a horrible design pattern to actually have to go get the singleton every time you want to use it. If you're doing that, I mean, there's something fundamentally broken with your model to begin with.
This goes to who writes this code, right? That's what you just said. And the answer is, of course,
everybody.
Well, who needs to write it? As I guess your point was, do you actually need to write this code? And there's a handful of people who do, and they want to know how to do it. And there's a lot of folks who, I'm with you, will claim they need to, but if you look at what the hell, where their performance goes and what they're doing, they don't.
Yeah.
Just fucking take the lock, dude. No one cares.
Yeah.
Okay, so the hash map entry set.
Quite frankly, I've gotten into positions where I'm looking at it going like, oh, I need to do this. And then you step back and look at things and go like, fiddle, bang. All of a sudden that need just goes away and you actually end up with something cleaner anyway. So, I mean, if you're encoding knowledge of singleton into your model, then your model is fundamentally broken.
Yeah. I wouldn't say it's fundamentally broken, but I definitely take a second look. There's a thing there.
Fundamentally broken. I'll go fundamentally broken.
Okay, fine. I get periodically called in to do performance work for people, and I usually get an integer factor speed up 2 to 5x. And almost always the code's hugely smaller and simpler. And so I'm with you on that one. You go to the root cause of the problem, you clean it out, things simpler and faster, both.
Right. But I mean, if you start taking away the knowledge of singleton to the rest of the application, which means they actually have what they need to work, then all of a sudden all the barrier issues go away. Then it's like, what the hell? Just grab a synchronization around, block around where the thing is created, and you know, you're not going down that path very often anyway, so who cares, right?
Cameron, you were saying something?
Yeah, I was going to comment on the hash map entry set concept. You know, that one does not require either locking nor volatile nor final. You just have a variable, you check if it's null. If it's null, you create one and store it and return it because it's stateless. I mean, everything it does just points back to
Right.
the map.
If the entry set consists of nothing other than finals, then it falls into that final
No, even
publishing.
who cares if it's all finals?
If the entry set has any non-final fields, then it wouldn't be safe. But that entry set probably has no fields at all because it just refers back to the parent
Yeah,
map.
has an outer this, exactly. It's stateless, or whatever state it has is just a cache or something. Yeah. So who cares if you accidentally create two?
Right. So yeah, so that's assuming the entry set implementation is stateless, then yeah, that's fine. But as a general pattern, that doesn't work.
It's surprising how often it does work.
Yeah.
Well, yes, right.
I'm with Cameron here on this one. I do a lot of these things where I'm making a thing that's stateless. It's the same every time. So we racily make two, and I don't care. They look the same.
Yeah, absolutely. If it's stateless, sure.
Yeah.
I want to come back to a comment Cliff made about fixing performance problems by getting rid of special cases and shrinking the code. And
not necessarily special cases. It's just usually shrinking the code.
well, yeah, if you make something more general, the special cases go away, and you don't have to think about that difference because it isn't a difference that matters anymore, and so things just go faster. How do we spread this philosophy around the world?
The usual way I get things to go faster is to get rid of things. It's not get rid of general case or make some specific case a general case. It's just to get rid of having stuff. So it's the cost of allocation is shockingly higher than you think, or most people think. Hey, it's a bump pointer allocation. It's really cheap. And the garbage collector says it's really cheap, right? And no, it's endless cache misses. And so the first thing comes around is you're duplicating the data that your main data in your main application is somehow being copied about all the time and change shape slightly as it's copied about. And the usual thing I do is say, okay, there's one source of truth and it's cacheable by other folks as needed, but mostly there's one source of truth, go to the one source of truth. And when you get rid of the in-between copying of things as they mutate their state along through the application from, network bytebuffers to JSON to DOM to God knows what all, XML and so forth, you get rid of all the layers and layers of translations.
So, Cliff, to that point, I would say that in the cases where I've actually had to refactor for one reason or another, and you end up looking at the code and going like, oh my God, and you do some things that actually end up with like code implosion, right? Where you just like drastically reduce code base sizes. An extreme examples, I once took a code base that was around 60,000 lines down to about 10K, right? Most of that actually had to do with normalization of execution paths. So there was some generalization there that allowed me to polymorphically treat things the same way. And I think that just comes into a design philosophy that's not well taught. I mean, the getter setter mess, in my opinion, has just really contributed to that whole thing. It's like, it's not that you're exporting just state, you're also exporting accidentally exporting or even implicitly exporting the logic to manage that state. And so that's an issue. Once you do that, then you generally, once you invert that thing around, and then you start you start looking at what's actually happening. When you start doing that, you find that there's ways of just normalizing the paths, which means that now I have one execution path. I can just focus on that, and I can just like ram the data through that, and we just have to deal. The things are basically behaving polymorphically in the system, as opposed to trying to special case all of this behavior by having all this branching stuff, and you don't get good branch predictions.
I would claim that you're trying to say so. Well, okay, I have a thing that I think is a summary of what you're trying to say.
Cool.
And that's the main observation I make is that there is a one main kind of data in the system, not kind in the actual object sense or the actual structure sense, but it's the one main thing that people are worrying about. Cleaning that up, normalizing and shrinking the data structure, the data itself is the main thing. After that happens, all the special paths that went to all the special variants of the same data all collapse down to a single, easy to think about path that can now be optimized to hell and gone. The first thing that has to happen is you have to get a handle on the wildness of the data, which is generally shadowy mirror reflected copies of itself. As somebody said, I have this version and I have this other thing, but I needed this little other thing, so I added to it here and I subtracted here. It was out of order here, so I did this and that. And they have the same core concept, and they have 1,000 little variants around it. And normalizing all those leads to this huge code size reduction and a huge speed up always round.
Yeah. So I'm not sure if that was shorter, but I do like it. So. Yeah, and I'd say that's a good summary of what I was trying to say. Is that's exactly what you end up doing, is you end up like actually taking a bunch of these things that don't really do anything, and you just like are able to put them through code paths so that where they're sort of treated the same, but they react differently to the treatment, and then you just get rid of all the special casing. At that point, it just runs through, and those code paths tend to be simpler and much simpler to debug.
Much simpler to deal with, yeah.
Yeah, absolutely.
Yeah, yeah.
And they just for some reason, this comes back to education, getting back to the earlier point, it's just that these types of designs are not taught. A while back, there's another point too, is that, and this goes back more to design also, and like how design influences performance. I wish I could find the talk. It was brilliant. This guy who was doing gaming at Sony said, our design concepts are all about singularity, but our processing is all about multitudes, right? We process, millions or billions of things, but we model as if we're only dealing with a single thing. And if you actually change the modeling concept so that the models actually reflect this, then you end up with code that's actually able to manage this much better, much more performant.
You want to see if you can find a link?
Yeah, I'll see if I can dig it up. It's been quite some time. So like one of the things they said they were getting was just simply, like right now, if you look at the like cache lines, right? Cache lines are generally about 18% utilized for code paths. 20% maybe, so some small percentage of the cache line is actually useful for each calculation. So the cache lines don't get packed well, right? And you can't, and yourself, you can affect how cache lines are packed by simply altering some of your design things that you're designing. And of course you have to understand how, the compiler is going to lay out, and the runtimes are going to lay out the data and stuff like that. But once you start taking that into consideration, you can get, instead of getting, cache lines that are only 18% useful, you can start upping that number closer to, the 100% value that you'd like to see.
It's all about the data.
It's all about the data.
Yeah.
Absolutely.
So this thing that I got in my head that I want to say is Shannon's law, and it's not. but it basically says there's a lower bound in the amount of information that's kept in a program, application, heap, whatever you want to call it. And if you were to try and use a classic compression, you could asymptotically push a lower bound, but that's not where I'm going. There's a lower bound of the kinds of things you have to say the kind of things that need to be said for this application. And most applications are hugely far above that, and that they have saying the same thing over and over again, but in many different kinds of ways, and getting rid of all the data duplications that say, and yet here is another way to say a person, here's another way to say a person, here's another way to say a person, is part of the shrinking of the data structures. That turns into shrinking of the code, turns into better performance always around.
Pitfalls of Object-Oriented Programming by Tony Albert.
I don't recognize either one of these. I've seen the Pitfalls a long time ago.
Yeah, it's Pitfalls of Object-Oriented Programming. Now, I'd say the Pitfalls of Object-Oriented Programming as it's normally taught is the problem. Object-Oriented Programming is fine. It's just often taught incorrectly.
Oh, here's your Sony fellow, though. Yeah.
Yeah, that's the guy. I think that's the talk right there. It was an interesting talk, anyways.
Right. What is OO? Data encapsulation, blah, 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 reuse, and where it came from and where it goes and why. And you can get a lot of this stuff. Oh, look at these ads. He's got ads from a TI-99. Black and white. Holy shit. I swear I've seen that ad. Processor speed modeling. Yeah, he's going down the whole, it's all fast, slow, whatever. Yeah, one of the and he's doing the layout game. Right, exactly. So once you decide that you are in the realm of needing to do performance work on some larger data, it really pays to think about the data layout, especially as it lands on your caches. And there's things to be done there. Mostly, structive arrays versus array of structs is generally hugely more performant. All right, I think we beat this one to death. Let's do something different. So Cameron, what are you doing for short circuit operators in language syntax?
Oh boy. So first thing I have to explain is we don't call the and or, et cetera, short circuit. So this is not short circuit. This is not short circuit. We actually use the term short circuit to mean something special. So these, I forget the term that we use for these, but yeah, they work the same way as they do in Java, but we don't call it short circuiting because we use, for example, the null check. So if I have A.B.C.D.E, and any one of those could be null.
Yeah. Yeah.
Those are what we call short circuiting operators, meaning that they actually require a ground. So if you think of it in electrical terms and keep in mind.
You're going to an electrical analogy here. Oh my God.
So keep in mind, I have no training in electrical or
I have a double E degree, if that helps.
I have degrees in absolutely useless stuff like, Spanish literature or something. Actually, that actually sounds really good. So let me.
I was kind of surprised. I thought you didn't have any degrees at all.
Political science and economics.
Well, at least you have a paying job.
At least economics is useful.
So these are all short-circuiting things because from any point, if it hits a null, it looks for ground.
Yeah, and it nulls up.
But of course, it doesn't do that at runtime. It does it at compile time. So the compiler says, to compile a question mark, it says, hey, anybody, and it doesn't know who's above it, if you will, in the ASD tree. It says, hey, I need someone to tell me that there's a ground present because I could be on an ungrounded plane, if you will. So the expression itself says I need a ground, and the cool thing about it is that you can say, A question dot B question dot C, and then you can provide a single ground. And I stole this from another language. I can't remember which one it is.
So this is, if one of those is null, you return back a D as opposed to a C?
That's right. So it's this, and you've seen this code all over the place. Like if A is null, then do something like there's some
You have a
default.
short circuit or whatever. You have a way to give a value when
if
somebody bails out in the
B
chain,
goes- right.
as opposed to returning a null, which you could then test on and then return the value. Which is not a hugely more shortened, isn't it?
So in this case, I put kind of shorthand here because it's like if A is null, then do the default. Otherwise,
right.
A dot B is null, then do the default. Otherwise,
I usually
if
break
A
it
dot
in
B dot,
2 lines and say result equals the A equals null, not null, blah, 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 blah. And then if result is null, then it's the default.
right. So this,
So the D here is an expression. I mean, is it a expression you return, or you can have arbitrary code there?
it's expression. These are all expressions.
Okay.
For me, everything's an expression. So I would do this same thing for the same reason Cameron is, but it would be anything because all things are expressions.
So the thing is, A question mark dot B question mark dot C question mark dot D question mark dot E. If you wrote that in Java, it would be something like 30 lines of code.
Yeah, it stretch out quite a bit. Yeah, I often do a one where I do the line by line by line, stripping the null as you go. So it's 1 line per null question mark because I don't have any better answer.
Right. And so this works out quite nicely. And then, but then the short circuit goes to the colon operator. So, you have that dot, dot, whatever the short circuiting thing is. And so it's illegal to have that colon D if nothing can short circuit. And then of course you can parenthesize it. So in theory, you could say, A question mark dot B question mark dot C D.
So you're illegal if you can prove that a D can't happen. It's just a version of dead code.
Right. So the compiler says, hey, this, but so the compiler tries to prevent you from having, in general, tries to prevent you from having dead code.
Right. No, it's right. It's a sign of broken thinking. The compiler's supposed to step in and help you here.
Right. And then the interesting thing as well is because there's this Elvis operator. So like A question mark colon B says, use A. You evaluate A, and if it's not null, use it. If it is null, then use B. And what's really cool is this is the same as this. So there's a, if you think about it, it says use A, but if A is null, short circuit, go until you find the ground and use whatever's after that.
Well, okay, because there's this version, which is use A if A is not null, and if it is null, then use B.
Yeah, I prefer Elvis.
I'm an old school seashell, shell and seashell.
Right.
I'm always doing this version. I haven't decided if I'm going to go that far down the Elvis path. The first one you did there with the question mark colon for a short circuit on a load looks really good. But the last version there where it gives me 2 ways to write the same things. So basically you except A is only evaluated once, but you're writing it as this.
Oh, so that's the other thing, right? Is to make sure that things only get evaluated once.
Yeah, including all side effects. That's part of the deal.
I was going to ask Cameron, why are you swearing at us?
Side effects.
Yeah.
I do side effects all the time. Yeah. I'm not getting away from side effects. In fact, I'm trying hard to make it reasonable to reason about side effects and what I'm doing with AA. They can be available, they do sensible things, and you can be fairly type safe aggressive about what you're doing with them. So that's my theory. But I do them all the time.
Question? What's the dot for in this case?
Which dot?
Yeah, exactly.
It's a dereference.
Yeah, like a load. A dot B. Load field B from pointer A.
Right. And in Java, that throws in all pointer exception.
B, okay, so the short circuit. Okay, I'm just trying to wrap my brain around this wacky syntax. So you say, if I'm looking in the middle under the default there, that's A short circuit to B to C to D.
So A question mark dot B compiles as if you said A temp, well, sorry, if, I'm going to write it in C style. If A temp equals A not equal to null, right? Then
we can't see it till you hit the enter button because we're not on a whiteboard.
So
there you go.
So it does that evaluation first, and then it says the equivalent of a return B, A temp.b. So in other words, it only evaluates A once. And of course, if A is a register, it doesn't have an A temp. So that's all done by the.
Well, the A temp's just the compiler doing its thing. The optimizer cleans it out under the hood.
FIFO.
Yeah.
Yeah. So, but the nice thing is that it strings it together. So, so the A question mark dot B.
You have another syntax there, right? You have the A question mark standard trinary syntax. If you're missing the middle thing, you just take the predicate. And I have a version that says, so you have this, you have question mark colon B, which is, right, it just says if you syntactically skipped the middle thing, you're taking the predicate as your value if it's non-zero, otherwise your value would be fine.
Yeah, so they call the question mark colon, that's called the Elvis operator.
Right. Well, you have two operators. You have a trinary version and you have the Elvis operator both, where the Elvis operator has no space allowed and you're tokenizing it as an operator, as the Elvis operator, as opposed to as a trinary.
Correct, but it has the same, so A question mark is A, but only if it's not null. A question mark colon B says take A if it's not null, but short circuit to the colon and take B if it is null. Yeah. And then A Elvis B has the same effect in that it's the first expression unless it's null, then the second expression. But the nice thing with the trailing question mark is that you can do that style. So it basically you don't require, there's no requirement of a colon for each question mark.
Oh, you're parsing the question mark by itself.
That's correct.
The question mark dot is not an operator, it's question mark.
Oh, correct. So some languages do question mark dot. I thought that was bullshit, so.
Okay. So wait, so a question mark.
That's right, is an expression.
Which evaluates to what? Null?
No, it cannot evaluate to null. That's the point. So A question mark evaluates to the non-nullable type of A.
Okay, and if A is null at that point, the compiler is blowing an error at you?
It depends on context. So a statement, for example, is always grounding. So if I say A question mark dot foo, for example, foo does not get called if A is null.
Okay, so you run the I'm null, skip it out to the end of the statement.
So the A question mark, the AST node for the question mark says, whoever you are that holds me, I need a grounding point. And it comes back with a grounding point, which is a label.
Yeah, I'm running in a different world than you.
Right, so if it comes back with a label, it says, okay, if the expression evaluates to null, jump to the label, right?
Right, and what's the grounding point? If I have a complicated expression.
So a statement always returns a grounding point, which is the end of the statement. And I think there's one exception to that, but in general, the statement acts as a grounding point.
What happens here?
If A is null, that operation does not occur.
Okay, what operation does not occur? The call to foo, or the x plus y?
So that's so that's not a legitimate statement. So z equals x plus a question mark dot foo plus y. So z will not be assigned.
Really?
Yeah.
Really?
Yeah.
Okay, I would claim that's unexpected behavior, that somewhere in the middle, you blow something and you don't do an assignment.
So we had that same rule when we went into this, and we found that that rule was not fun. In other words, we didn't allow, we were very explicit where we allowed the short circuiting operations to occur. And then over time, actually using it, we found that that was unhealthy.
Does it mean that before you evaluate an expression, you first need to evaluate all these operations, like short circuit operations, to decide whether you should start evaluating everything else?
So we chose not to do that. We actually continue to process it left to right, and so we do it as a short circuit, and that's why we use that term. So it's evaluating left to right, and when it hits a null that has the short circuit, then it goes to the short circuit for it.
And you have to know where the short circuit point ends or begins, because I can write complicated expressions with nested assignments in here pretty quickly, and I think it would be, I don't know, it sounds like it becomes confusing fast as to when you short circuit. Yeah,
So
exactly.
You would think so. Yeah. So.
Is it called bar or not?
Not if A is null. It turns out really, really simple.
Okay.
I can only tell you from using it.
You know, I would claim that you're doing.
And keep in mind that assignment for us is not an expression. So that makes a fundamental difference in the number of ways to blow your foot off.
Oh, right. Okay. Yeah, for me, assignment's an expression. And put it everywhere
I think that's one of the flaws in the C language, sorry.
Yeah, I like it.
Oh, I love it. I absolutely love it, but I think it's a flaw. Yeah.
So I would claim the version I wrote is a cleaner to understand than the version that has the question mark in the middle, other than I'm evaluating A twice. But you know, there's things doing evaluations.
Languages are idiomatic, so it is quite easy to write bad code in any language.
In any language, yeah, that's fair enough.
So, you know, so we were quite worried. We did not allow short-circuiting operations to occur in arguments for a method. And that was because we thought this is just horrible. You could evaluate the first argument, you could evaluate the second argument, and you get to the third one and it short circuits and you don't call the method. That's the most horrible thing in the universe. And so we were very explicit, like, no, we're not going to allow that. And within weeks, like the feedback was, no, we have to have this. Like it was a 180-degree turn.
After you do the evaluation and it blows, you keep the side effects of evaluating the args?
Yeah. And
you know, Jordan asks
because idiomatically it works well. Like I wouldn't want it in Java, but you know.
Yeah, I think I'm with Cliff. This is, I'll call it unnatural, but maybe your experience.
Yeah, we did not expect to come to the conclusion that we did.
How does that possibly work?
Well, he evaluates. So the thing I just wrote, he evaluates
method call.
Evaluates side one, gets side effects. Evaluates side two, gets side effects. Evaluates A, discovers it's null, does not call foo.
Well, you're assuming that the language says you evaluate left to right, which I don't know yet.
Yeah, we do left to right. Yeah. So that would do side one, that would do side two, and it would not call foo. And yeah, like I said, you can write ugly code in any language.
Yeah, fine.
And I guess the same applies to the example where we have z equals x plus short circuit plus y. So if x and y have some side effects while evaluating, you would still evaluate x and y, have the side effect, but not.
You evaluate x.
But not y.
Ah, okay.
I guess you could pretend that, for instance, this full call, the whole thing is wrapped inside a try-catch block that catches a null pointer exception
That's right.
thrown by a question mark and then just does nothing.
That's a good answer. Yeah.
Yeah,
I mean,
and the compiler helps you too, because like then you try to use Z and it's like, sorry, Z's not assigned, right? So, but in general, the reason the null stuff is such a help is because where you need nulls, like it turns out to be quite obvious, right? Like I have something that could be nullable. The compiler doesn't let me say A.B because it's nullable, right? So I have to say a question mark, like, and you just
and as soon as you know that you have a nullable and you're screwing around with it and it's not null, you know you have to bail on some point. Where's the bailout and when do I do it?
Although when you say that compiler tells you that Z is not assigned, do you mean statically or during execution you can, like, how do you deal with the situation? You have this Z which you don't know whether it was assigned or not. Like, what is the handling after that?
So basically what I'm saying is if I said, int Z equals a question mark dot B, and then I said int Z2 equals Z, that second line would fail. Anytime I try to dereference it, because it's not definitely assigned, the compiler knows that.
But how do you use, like, probably you need to have some construct to check whether it's assigned or not, so as to use the first Z. Like, how do you use the value which was produced by this short circuit operator?
Well, you don't. I mean, it's a compiler error.
But how do you know this statically? Like,
the compiler just looks at the code and says Z's not assigned.
I think the
can happen.
important part is it's not definitely assigned, right?
Right.
Yeah. It can happen differently in runtime. If you have a null pointer there, it will not be assigned.
We don't have null pointers.
Well, what are we short circuiting on?
The object is a null object.
So in runtime, depending whether you have null object or a regular object, you'll have different behavior. So you would either assign Z in this case or not.
Right.
So how do I use Z after that?
The compiler would not allow you to compile that because you would be trying to use something that's not definitely assigned.
Right. So this would give below a syntax error saying Z is not definitely assigned.
Right, exactly.
But what's the point of such an expression if I cannot use it after that?
Every language allows you to write stupid things. The question is, which languages have compilers that prevent you from routinely writing stupid things?
Okay, so this is a safety measure to prevent possible math with short circuit.
So
in theory, but we've never actually run into that. Like just because you wouldn't normally do that, you wouldn't normally write that code.
so I'm still trying to think about this, like in a reasonable normal flow, and maybe that's the problem. This is, you have to really tilt your brain to think about this the right way. But like if I have something a short circuit and I don't get this method called, and I need that method called for things to happen. And
no, it wouldn't have been called in any language because it would have dropped to the debugger, or it would have thrown an exception.
Well, that's what I'm looking at. Is like, okay,
it would have seg faulted.
In other language, I would do something stupid that would say don't bother calling. But at that point, I have the knowledge that that didn't get called in the code, right? So just by having it sort of magically in the background, decide, okay.
But again, it's not magic in the back. It's not magic in the background. You write it that way because you know it could be null and you don't want it to call if it is null.
That's right. But it
sticks out like a sore thumb.
But at the runtime, okay, so at the runtime, I don't know if that's been called or not. I mean, I've written it with the knowledge saying if it's null, don't call it. When I get into the runtime, it's, rubber meets pavement. At that point, it's like going like, well, I need to know if that's been called or not.
Yeah, we use the same opcodes as written state. I mean,
so
there's no special opcodes.
This didn't get run. I need to do something else.
Hey, Kirk, if I instead of the Elvis operator, if I wrote this code, So if A is not null, I'm calling the foo I'm using A.B. But if it didn't get called, I go to whatever my default handling is. Is that more obvious?
No, I mean, yeah, that code I understand. It's like just regular code. It doesn't matter. But using Cameron's syntax, I'm trying to get, what's the hint that I get back that, hey, this thing didn't get called. So if you wrote your code, like Cameron, using Cameron's syntactic style.
They're back to back now, the two syntaxes.
Oh, that's what okay, it looks like that there. Oh, okay, that's
Sucks less?
Well, it's not that it sucks less, it's just I just didn't understand it, so I didn't know.
Okay.
I mean, I couldn't put a suck.
Here's another way. Cameron, what if you got multiples of these in the multiple unrelated ones? Question mark dot B, C, question mark dot D.
I mean, say I'm warming up to this idea.
Yeah, I mean, I like the idea because it just means that, things are going to happen without me having to do anything.
So exactly, Cliff. That's exactly.
So when you say this sucks less, I'm going like, I'm not, I just wanted to see what it was, right?
Yeah. I'm not putting any judgment calls down.
Yeah.
I'm staring at it and thinking, it's not what I'm used to, so it's changed. Change is hard. What the hell? But maybe it's not bad.
So Mark was there when we designed this, and we explicitly Mark that Mark.
Oh, okay.
Hey, me, Mark.
Oh, so you're responsible for this?
No,
my comment was always this is not Java. I'm scared, and then we go through this exact conversation. I'm like, oh yeah, I think I like this.
I remember saying this is Java. I'm scared. So
So I still have a question on what I just wrote. So in this guy here,
if A is null, it goes to ha. If C is null, it goes to ha.
There's no way to break out the A and C is to go to different defaults.
Of course there is. You can say foo A question mark colon B colon first default, right?
The defaults go as close in as you can put the defaults anywhere. You see, and then you get scoping rules now. But go ahead, finish your example.
So remember in Sweden, I told you need to just start publishing more code.
Yeah, we've got like 60,000 lines of ecstasy published.
Well,
and we're about to publish a database.
Well, okay. I mean.
So you put the default, but the default covers the entire statement.
No.
Oh, it covers just right there.
So the colon expression is the actual bottom of the precedence table for expression operators. So basically, it sweeps everything to the left. It's kind of like if you look at the AST design, for Java, the tertiary operator is special. It is like the bottom of the swimming pool, right? It's like I'll grab everything up, so it's like it's a parsing trick that Guy did, I think. But basically the colon operator is the same way. It's like anything that short circuits up to this, that's mine, right? But it's within the AST tree, right? So the colon, for its scope, the colon is at the top of the tree, right? But I can also say A question mark dot B colon C question mark dot D colon E, right? Because that colon E is the top. And so within that, I have I don't know if I'm the right way on your screens, but the colon for the E is at the top, then the colon for the other colon is below that. I don't know if
they associate.
That's the way that they associate. Yes, that's exactly right.
No, left to right or right to left, or can you think of an example where it matters?
Because I'm doing recursive descent, I have to give me a second to flip it in my head.
if A, B, C, and D, E all have side effects, it matters, right, in this example. So if A is null,
then it goes to the C.
It goes to the C. Okay, that was the question. It goes to the C and evaluates C, including its side effects.
Right, and then if C is null,
it goes.
Yeah, I claim this example doesn't. It doesn't matter because if A is null, we're going to do C. But A if not null, we're not going to do C.
Correct.
Yeah. So it matters because you get C's side effects or not, according to whether A is null or not.
Right. So let me draw it with parentheses to kind of emphasize what I mean, because that's usually how you do it, right?
Yeah. This is your associativity.
So my question is there an example where you would want the parentheses the other way around?
Well, you should be able to put them in, right?
Yeah, but this example, it doesn't matter.
Right.
The way I read it.
Right.
That doesn't matter whether you put the parentheses on around the first colon or around the second one. The effect is the same.
Is that true?
It's right associative. And since it's left to right processing.
But if you put parens around to force less associativity, it's going to matter, right?
Yeah, but if something is null, it's going to go to ground anyways. Doesn't matter.
No, but you get different defaults accordingly.
No, but if A is null, or A is not null, then we get A dot B. If A is null, we get C question mark dot D, right? And either that's null or not, or if C is null, then the only in that scope, the only default is E.
Right.
It's the same as the first example with the parentheses the other way. So my question remains, is there an example we can come up with where the precedence matters?
Right.
Or the associativity matters, rather. It's like multiplication. Yeah, we usually do it left associative, but it doesn't really matter for a lot of things.
Right.
Yeah, I don't have my brain in parser mode right now, so I can't.
I'm with him, though. I would expand, to answer that question, I would expand this in a pile of ifs because I have an easier time sorting in my head because I'm the syntax I know.
Cameron, do you have a parser in parser mode?
Yeah, of course.
Oh, you could just use that to check out what it does, right?
I'm actually looking for it right now.
We don't need your brain in parser mode. We need a parser.
Yeah.
So hopefully the documentation is correct.
So under this model, I don't know that I'm with you. I don't know that it makes a difference. And this example doesn't make a difference.
Yeah, on line 613, it says it's right to left associative.
And is there, and then is there an example that matters? But that's fine. That's interesting.
I can't think of any off the top of my head, actually.
Well, I'm still staring at it, thinking I'm not clear. I like the throw out as if I, MPD somewhere in the middle and bailed. I definitely like the question mark dot as a short circuit for carrying along a null, independent of a default, but the throw out of the surrounding call.
I hear you. I hated the idea myself when we started.
And
so
now you claim you love it. Or you have a user base that loves it.
I like it.
Why?
I don't know. It just seems kind of like clean. It's like none of this, like if I look at your code and I look at that code, I'm going with that code.
Well, the whole blowing the nulls out is excessive. I agree there. That one looks ridiculous.
I was trying to emulate Barbara when I was looking at Liskov, and I just hated it to start because it's like, first of all, it's kind of unbalanced, and second of all, you build up kind of a mental stack of things that are going to happen, and then suddenly you're 5 levels up, and you say pop 5, right?
Right. And how far out do you pop? I mean, I'm not saying you.
That's why I hated it. That's why I did hate it.
Know how far out you're popping, like there's theoretically, but can your eyeball pop that far out reliably?
And it.
Yeah, I guess it's a compiler, right?
Where my answer is no.
Wait, Cameron, you dropped for 10 seconds, and then Kirk stepped over you. He says, Cameron, go again for a second. Hang on, Kirk.
I was just saying, I am sure that there will be people who write code that will make me regret this. But
no problem.
Yeah.
Yeah. Well,
No,
everyone.
I was just saying, like, I'm sure as a compiler writer, you hate it, but as an end user, I'm looking at it going like, wow, okay, this, yeah, I'm happy here. It's a little bit cryptic, but
It's right. I'm still wrapping my head around. You've popped some layers out until you found the colon that ended, or you have a statement that ends the expression. Like I don't have any statements per se.
Yeah.
It's all everything's an expression. So I don't know how far I'd have to stop the pop out. I do kind of have statements, and I have function boundaries, which is an obvious other place you blow out on.
So I mean, it's definitely readable. It's certainly not Scala.
Hey, Zen, I don't know how you pronounce that. No, you have to have an edge per edge. If there's 2 input edges to a multiply, there's 2 output edges from the multiply source.
So there's the parser. So we parse basically any expression other than the else expression. And it's an if, not a while, which makes it left us. Oh, geez. Like it's so hard to translate back and forth between Bacchus and.
I always do these things in the debugger where I have all my debugger 2-string printfs like lighting up the syntax in the right way so I can read it, and then I single step. Oh yeah, it's doing it this form, or I have to restructure the tree this way or whatever. And I'm not actually building a tree anyhow, so but I have to have a tree in the middle somewhere. Yeah, writing it.
That makes it right associative.
Hi, I just wanted to share something that I've been working on that it's more or less in the same area as Cameron. There's the concept of a functional effect system, right? So you can have a way of encoding effects like throwing an exception or handling null pointers using an effect system. And it's based on this paper. It's about a language, it's a small language. And I'm working on a variation of that. That is basically like instead of using syntax for that, you have a more generic mechanism using what I'm calling effect rotation. Let me show you an example. So you can have something like this. So you basically like you can have a value A, and you say it's an option of 2, so it's going to be defined. But then you can, through the type system, rotate the effect, saying this is an integer with an option effect, right? And then you can use that value, for instance, like x plus a dot full. And as a has the effect of an option, that's going to be tagged along. And the return value of the expression is going to have that same tag. So if a was empty, for instance, b is going to be empty as well. And then you have like options for rotating back the effects from the value to the rotated position. So it's something, it seems to be pretty...
The option
go ahead.
poisons and spreads to the surrounding expression. If any subpart of expression is optional, the whole expression is optional.
Yes, if you have an effect at some points of the evaluation, that effect is going to continue. And that's valuable if you have like an exception. You can also use the same mechanism. If you have a side effect, you can also model side effects as values, so you can tag them as effects as well. So you can have everything pure, and then you can use the type system for rotating effects from the rotated portion to the top to the value, or from the value to the rotated part. It seems to be really good in terms of it's very generic. You can do like the optional, you can do exception, you can do side effects, all with the same kind of mechanism. If you read the paper, it's probably going to be more clear how that works.
So in the case of exceptions, the exception poison is that the expression as a whole is typed as either an exception or the following thing.
Yeah. And
then you just carry along until you decide you want to disambiguate, I got an exception or I got a thing.
Yes.
Okay. So the Elm does a very similar operation. Although you don't, the syntax is, I claim a little cleaner. He basically demands that you declare B to be an option type. because it won't type properly. And because he does type inference, he'll just type it as option, but he won't let you do x plus a dot foo, and that way you have to say option of. There's a way to make it. Maybe operator.
That's something I do as well. So if you want to rotate the facts, you have to do it through the type. It's if you just do like vol a equals option 2 and try to use it as an effect, that's not going to work. You have to rotate the fact through the type, saying the type is like with the option rotated and the type is each integer, for instance. So you have to explicitly say, I want to use this data type as an effect, basically, through the type system.
Okay, so in your expression where you write b option is int is x plus blah, 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 and x is a plain int, somewhere in there you've decided that you are either extracting an int from a.foo and wrapping the whole thing in an option if a is not. So you're testing a first. So if I have a whole lot of these a's variants that are all optional in there, you're going to test them all and then you're going to extract them all. Like what's the order of operations here?
So it depends on the fact. So if it's an option, it stops at the first one. It's like a null pointer, right? So it's going to short circuit at the first one. But you can have different types of effects, and then you can implement them in different ways, right? So you can have different effects composing with each other. So you can say like you have a side effect, but you also have option. Depending if the option is first, the option as a side effect is going to stop the side effect before happening. But if you rotate the side effect first before the option, the side effect is going to happen depending if like the expression can be evaluated through the side effect. So it depends on how you compose effects. The order of like having option or throwable or side effect on the rotated parts influences how things are going to be evaluated.
So when you say side effects, are you talking about add a atomic integer, add plus plus?
So I'm encoding everything as values, so it's lazy, right?
There's no actual memory side effect.
Yeah, basically it's only allocation. It's saving a plan for later execution.
Yeah, saving, right, fine. Yeah. Yeah, so there's always those things are questions about performance, but that sort of remains to be seen. The obvious fail is that there's no efficient implementation. But I don't know. It's an open question.
It's actually very similar to what Cameron's implementing, but I think it's more generic. It's a way of looking at this problem as something generic. It's an effect system, not something like ad hoc for specifically null pointers, for instance. It is what normally languages do that I don't like, having something very specific for a specific effect. It's at the same time, it's the same thing for exceptions, null pointers, and etc.
Yeah, I largely agree. Nulls are a pain in the butt, and having anything special, I think, is a pain in the butt. But it's like you make little exceptions, like for nulls, just because they're so common in the use of a language. And in our case, we don't have the real null that Cliff likes. We don't have the 0 equals null equals 0.0 equals false.
Yeah, there's a different one though. There's a notion of not a thing that everyone likes, and how you represent it is different. In my case, I'm happy to have it actually be the hardware 0 because of the efficiencies that come from that. But I have a strong type system around it, so I'm okay with how thinking and managing the null. That one's fine. Roughly I can do all the syntax things you're doing with the hardware null.
And we do the exact opposite and come to the same exact code production, which is it's a 0 on a register. Yeah. Right. So hopefully there's an optimization that you boil it down to 0 on a register anyhow. In my typing system, it's a thing that's basically a 0. And it's not necessarily a subtype or supertype of everybody, but it's because I'm doing a lattice theory instead of sort of a tree-based thing. It's a little different. So Flavio, I haven't read the paper yet. So what? This is a language you're working on?
No, the paper is of another language, and I'm inspired by that paper on what I'm doing. It's a little different. I'm doing this rotation of the effect. It's different from the Frank language from the paper. But I think if you can read the paper, it's a nice read. It's a nice paper, and I think like thinking of this as something more generic, like as an effect system, is something really powerful. And if you see like things that we do in Scala, doing like monads and effects through monads and using far comprehensions, or even like I wrote an async await, generic async await for Scala, where you can transform regular codes into a monad, and that allows you to do like effects, this kind of effects, in a more principled and easier to reason way. So yeah, it's a nice read. I really recommend the paper.
So so the effects thing would handle well range check elimination or range check errors. Is the other sort of major type fail that I can't get rid of by demanding reasonable compiler typing.
Dependent type system.
Yeah, well, right. So array references can blow out of range. You can stack overflow. You can out of memory. You can be null pointers, the obvious other one. Other types are always checkable by the compiler. If you're a person or an integer or whatever, and demand you put a user written test as needed. I've been trying to sort out what to do with a range check blow. Like null pointer, we've all beaten down here pretty hard. So what do you do with a range check throw? And the code's not safe because it can throw a range check exception. And where do you stop and catch, and how do you deal? And what I heard Flavio say is we localize such failures into a tuple of a failed or I got a value, and there's a flag, there's a bit saying I success or fail with some optional range check, whatever, or a thing which is useful, and then I want to sort of promulgate that about it. And some of these
that would be like you could return options right from getting value from an array in case if it's not within the range.
I've coded that style with Elm and it sucks. As a user of dealing with option out arrays, it sucks. I would have loops where I knew damned well it shall not throw a range check exception, but I couldn't tell the compiler that. And yet every time I grabbed a value using Elm array get, I had an option on it, and I had to peel the option out. And I had to have the option peel say, and if you got a null, you must have blown a range check, do this. And do this was never useful because I never could hit it, but I had to write the code. I could not dodge saying and option. So it sucked. And I went to promulgate further and further afield the exception with no syntax up until even the program would halt if you throw a range check, which is what Java does. It throws a range check exception. If you don't catch it, boom, you're dead. But you get a nice polite error message. But if you write your code right, it doesn't ever throw, and so you don't care. You don't want to deal with thinking about what to do on a range check when it can't even happen. Or if it can happen, but it's not happening right now, and I just want to get my lifeline. So there's a thing there where when you finally decide you want to deal with this code throwing an exception, you had to be in a place and a time where you can have a respectable cleanup. And that's usually like not where you're through the exception, but it's many, many layers uphill, including all the way out to the top of the process, and your process dies.
Yeah, I think you can't do much better than that, right? Something I'm trying to do, and it's not working yet, is basically doing static analysis and using full typing, right? So I'm checking and like trying to propagate all the states possible, like at this point, some points of execution. So I can say it's always going to be within range at this point. But that's not something really hard to do. Right? So
as soon as I do
it's only a few cases you can do that.
Right. As soon as I do something fancy here, you have a range issue that you can't deduce from the compiler, right? Like maybe my mod function in my hash table, you can see mod, but if I have a reprobe loop where I do something like I add and then I bound and I wrap or whatever, I can get more complicated than any compiler really fast, really stupidly easy in a hash function on a hash table. And I just don't want to have to write the syntax that says, and on a range check, do this. Because it's never going to range check, but also the compiler can't prove it. So I want the compiler to test for it, emit the test is cheap, but the fail case can be abort the program, and the fail will never happen. So that's the least level of syntax, and that's the level of syntax I want to deal with.
So let me show you how we did that with,
Yeah, go for it. No, I'm looking for a better answer here.
One little difference is that in Java, throw is a statement.
Yeah, fine.
So we made throw into an expression. So for example, let's say you have a switch expression and you have a default branch, and it's like, it should never hit default. So you just say default assert.
Right.
In other words, return the assert. But it doesn't
okay.
actually return an assert. It actually raises an exception at that point.
Oh, I see. Okay. Yeah, fine.
So assert and throw and to do are non-completing expressions.
They throw as multiple function call layering out. Return from multiple function depths until you're caught.
Right. They literally throw. I mean.
Yeah. Okay.
Yeah. So for example, with that A question mark dot B question mark dot C.
Oh, assert is a throw, just straight up. With the express, so you put a yeah, right, yeah.
So assert with no parameter is the same as assert false.
Right. No, that's really nice because the test can be before, can be after. The only thing you get out of a Java flavored assert is you can turn it off for performance reasons, presumably.
Right, and so we can do that with assert test. So you can only turn tests off.
Oh, okay.
So asserts are not compiled out by they're actually executed. Which is
okay.
Which
if I want to have an expression which is complicated on my assert and get rid of the expression. An expression with side effects inside the assert, yeah, bad boy, don't do it. Fine, I'm doing it. How do I write that so I can get rid of it if I turn it off? The obvious place I get side effects, by the way, is I call some complicated thing that tests some complicated invariant, and internally the complicated thing caches computations, so it has side effects.
Right. So, I mean, is that what you meant? Like some?
Yeah. So if I say no tests, then foo never gets called.
Right.
The other one is you have a bunch of string concatenation for the error message that I don't want to actually allocate the string bodies and do the concatenation and a giant math pile. And it just have it go away when you say assert false or turn off asserts. Okay, fine. So there's a way. That's all I wanted to know. Because
right. We do all this. We do all the string stuff for you. So if you say in I equals foo or whatever,
but I can have pretty complicated string math in an assert normally. No. People write something.
I thought you meant for the debug message, because in this case,
I'm writing a private debug message in my assert because I have a complicated situation and I want to remind myself, here I'm blowing this invariant where I expect blah to be less than blah, but blah to be greater than blah, and I write out a long ass thing with a lot of concatenations of interesting parameters as part of the assert you die now message. Right, as opposed to just echoing the line. Like in C, they just take the line as a string, the textual source code line as a string, and throw it out for you. That's a great starting point. Sometimes I want something more fancy. In Java, I write it all the time.
So what we do is the AST nodes, the expression AST node for the assert is asked, are you interesting? And it's like, nope, but let me ask the AST nodes under me. And I, being a local variable, says, yes, I'm interesting. And foo, being a method, I don't know if it is or is not. But basically, the interesting things register themselves. And then the string concatenation is all done for you automatically. It prints out all the interesting things from the line.
Oh, you've extracted the bits on the line.
It's the compiler.
Well.
The compiler.
Oh, that's a really handy hack. Oh, I like that one. No, it still wouldn't solve my problem where I'm finding out a fancy thing that I'm trying to say something complicated because the variables in question aren't on the line.
Right.
For the assert, but having the assert blow by dumping strings that are nearby or variables nearby, that's a really cool hack.
Yeah, it's
by the way, you have a giant security hole there as well.
Or you can turn it off.
Okay, fine. So, oh yeah, right. You just turn asserts off. Done.
No, sorry. You can turn off. There's a visibility thing. So by default, we build the source code into the compiled thing as well.
Right.
Because the debugger runs against the compiled form, and it just it's a long story. But we have any number of versions in the compiled form. So when you load it and you're debugging it, it's like, where do you get the source code for version whatever? And it's right there.
Yeah. Java throws it in the jar file, which disassociated, and sometimes you don't get it. And now there's a robust market for Java decompilers and all that kind of shit. Fine. So yeah, back in the day doing H2O, we had to deal with missing types in a big math thing, and we got a little more clever. We broke the data up, so the data would be terabytes in size. We broke it up into a couple megabyte chunks, so easy to manipulate, distributed, scattered, whatever, fine, parallel, blah, 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 all the right things. But when you went to a chunk of data, you compressed each chunk independently because it was big enough that the cost of computing a new compression strategy per chunk was small, and then you got better compression. All the compression strategies dealt with a null, a not in value, a missing value. And they did it differently according to the compression strategy. So if I'm compressing on things that are integer looking things in my 1 million ints, I pick a value which is none of the 1 million ints that are present. And we do, shift, scale, add, subtract, whatever to shrink things down, and then pick a value that's not any of the above, and that's your null. And the decompressor knows to do the reverse. So you would get a not available, not a number on all possible guys, generally by taking one more state space that wasn't being used in the current compression strategy.
Right, it's a handy way to do fat pointers as well, where you want to put ints in for fat pointers, is to pick a non-existent pointer / int.
Right. But I didn't do pairs for missing or not, because that'd be way more data space and way less efficient. It's all good. The only place that we ever did any games the slightest was we picked an unusual nan for doubles.
I think this pair is only for a tag. So you have the ordinary array, and then you have a very tiny array, which is more of a descriptor,
it's a bit vector,
which is a tiny bit vector that tells you which indexes may be missing. Right. It's interesting because then you can normally vectorize it with SIMD instruction. It's just, it's just like C array at this point, the first array of the pair.
Right.
So you can,
and I'm claiming I did tighter by a lot if your data was mostly small enums already. If I had the enums of the set of car manufacturers, and so I have 20 or 30, I picked one more state, and that was less than one more bit by a fair amount.
Yeah, I think R does something like that. So R has support for missing data for integers, and they basically pick one of the integer values.
Yeah, that's the way I ended up doing, picking one of the integer values, but I knew it wasn't any of them that you had picked. So you can pick any integers you want, and I always picked the one you didn't.
Right.
That's just part of the, the fun games. See, knowing for a fact that you're looking at columnar compressible data, there's all these compression strategies you do that are sort of like, why would you do that in general? Well, it doesn't work so well in general, but it works very specifically for columnar data. It works super well for columnar data. Like orders of magnitude better. Not orders, but I beat gzip on disk routinely. And in a form factor, I could decompress in registers in a handful, much less than memory bandwidth, in a handful of clock cycles. It was faster to never decompress, except only in registers, because your memory bandwidth was lower. If you ever decompressed it and put it back out to memory, you lost. So thou shalt never decompress except in registers. And then a handful of clock cycles of decompression is much faster. That was a fun one.
Did I see that you were on the list of the H2O? Wasn't that on the list of the top 25 Java projects or something that Oracle published for their 25-year marketing thing?
I have no idea. I co-founded H2O and I did all the core tech. Now, did Oracle come along and bless H2O? Maybe.
Yeah, I think it came out just a couple of days ago. Has anyone seen that, Archer?
This is a Google.
Yeah, and H2O was on there.
Oh, nice. Okay.
Cool. Congrats, Cliff.
Well, thank you. I walked away from H2O because my co-founder and I had a disagreement, let's say. Let's leave it at that. But I did okay. So it's all good. And I still use it. So all kinds of big data projects, I pull out H2O and go to town. Well, let's see here. It's 11:40. We have a natural break in the conversation. Anyone want to ask any questions or bring up any other topics here? Zin, you get your question answered? See if Zin's on the mic. I threw you an answer, but I didn't get a response that made it clear that we're all done.
It looked a little bit confusing to me as well. I guess I don't really know how the strings are printed. Maybe Zin can.
Hello.
Well, I can tell you what the strings are doing.
Hello.
Oh, he's back.
I'm here.
Did you get your question answered?
I'm still confused a little bit. Sorry. First of all, I'm new here. I watched some sessions, previous sessions. So my question is, how can I bring questions? Do I need to prepare? So, or how do you organize conversations or topics?
Okay. So it's an open mic, open conversation. People ask questions whenever they want.
Okay.
At some point, you pop up and say, hey, what about blah, 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 which is what you did in the chat. But then we rolled a long time and finishing out other topics. And I just now got around to back where you're at in the chat.
Yeah. The thing is, I don't intend to interrupt or hijack the conversation you guys you're working on. So that's why I just send a question in the chat room, like a side channel. So I don't want to interrupt you guys. And the thing is, if I want to bring up some kind of new topic, then do I need to send the question ahead of this meeting?
Slow down. You're being way more official than anything that's going on here.
Oh.
We're making it up as we go along. And yeah, Cameron says you should interrupt. I agree. You should interrupt. And if I think we're having a cool conversation, I want to carry on, I'll tell you, hang on, and let's finish out where we're at. Mm-hmm. And if we're kind of stumbling around looking for something fun to talk about, we'll pivot right away. So It's all good.
Okay, I understand that. And so my question is, when I work on those kind of CL nodes or ideal graph, I found that there are some kind of, multiple edges. There are multiple edges between two nodes. So you just give me a very simple example. Let's say that a square x return x times x, right? So I understand that there are two uses of this parameter. So my understanding, let's say that if I manage to reduce this 244 into 144, so I feel that it still works. I'm sorry. Let me put this back.
You got quiet suddenly, like you're not facing your mic.
Oh, here. Let me put it back in the chat room. So let's say that this is where I think you gave us a very simple example, which is good. So let's say I understand that there are two uses of this 44, because you return x times x, right? But so let's say that I manage to reduce this this parameter node to one single use. So what will it affect the later optimizations or code generation? I feel that it's still correct.
Okay, so hang on. So the graph is the graph is the graph. If there's two edges in one direction, there's two edges in the other, although the implementation in a C struct has pointers in both directions. The debug print just prints what the C has, what the C structures are. So you have a graph. Now, if you mutate the graph to a new shape graph, you do, and it does whatever the new shape does. So if you replaced mul with a squaring primitive that only takes one edge and squares it, that's fine, and it does exactly what you might expect. The only sort of caveat is to keep the edges forward and the edges backwards aligned. Otherwise, you don't have a valid graph.
Yeah,
right.
I understand that. Because somehow I feel that if there are like multiple nodes in the output in the out, so I have to have like a special. If I don't want to duplicate. I don't want to do this. Yeah, I have to have a special code to deal with.
Okay, hang on. Edges are really cheap. So you just have one edge for every use, and then you have the def use def edge the other way. And those are like insanely cheap.
Okay.
So there's no point in optimizing edge counts that way, but you're optimizing semantics to get rid of nodes, to do something in a different way. Then you mutate the graph. It's fine. It is also the case that because of the multiple uses, like your cast, that was a cast not null. That was a null check. Every possible load that was guarded by that one null check all hung off that cast. So that cast has got dozens of uses. Also, it may have a value that was null checked and then stored. And you may have dozens of repeated uses of various kinds all over the map. So, but that's fine. That just says that when you're going from a use to a def, every input has semantically different meanings. But when you go from a def to a use, it's all the same meaning, and you can have multiples, and it's all good. When you go from a use to a def, null is a special property here, meaning I don't have this edge, which is typically reserved for, it doesn't make sense to talk about this edge. When you go from a def to a use, you never have a null. Use def edges are ordered and have semantic meaning based on the order. Def use edges are unordered.
That's very important information for me. Thank you.
Yeah.
Ordered. Def to use is ordered. Okay.
Def to use is unordered. Use to def is ordered. If I have a division, A divide B, it matters B from A. It matters if I swap A or B. So use to def is ordered. But def to use is just, I got another use, I got another use, I got another use. All the uses are unordered.
Okay, got it. Okay, yeah, that's helpful. Thank you.
Yeah, no problem.
You asked the right guy.
Yeah. I have another very elementary question. I read your early papers when you in the Rice University and the HP lab about the C of node. When you in the early stage of this C of node, did you meant to work on for Java or like for C++?
None of the above. No Java was around then, so I couldn't have thought to work for Java. It didn't exist. So it was a compiler, and I was a PhD for compilers, whatever language was going to be compiled. So C++ was still brand spanking new, and it was hardly worth using, more or less compiling for. But Fortran, right? People were doing COBOL, people were doing PL1, people were doing a couple other languages that were floating around. So
Self?
I'm sorry?
Self?
Self came along later. I mean, not that it came along later, it came to my awareness later. So at the time I was there, I'd heard about Smalltalk and it was really cool to read, but there was no self yet. But I stared at Smalltalk and was like, what can I do here? But JITting wasn't really there yet. Now I'd been doing codegen during execution all the time since I'm doing fourth in high school, a long time ago. But to do it sort of officially with a serious heavyweight compiler was not a thing that I kind of sorted my head around until I got the C of nodes and the fast optimizer going. And at that point I was like, yeah, this is pretty damn quick and it's pretty damn efficient. Most optimizers were 10 times slower, 100 times slower than what I was doing for 10%, 5-10% more speed up for 10x, 100x slowdown. Somewhere in there, I came to the notion, yeah, I could do more and do it sort of dynamically, because I've been doing it for Forth dynamically, and then the Java guys reached out.
Yeah. The
reached
reason
out.
I ask this one, because I feel that your approach fits Java very well. But because, you know, in your paper, like from the quad to the nodes, so you mentioned that you put some optimization in parser. But let's say that you can do that because you are passing like a bytecode, which is well formed, which has been verified, right? But let's say that when you pass C++ code, you cannot do that, because if you run into some kind of syntax error, you cannot give like a correct error message, because you have already optimized some codes.
No.
Resume the information.
So back up. You're talking about how to de-optimize and how to debug optimized code.
No, I don't mean that. I mean that. So I understand that you put some optimization specifically in hotspot. You in C2, you do some kind of global value numbering when you are passing the bytecode, right?
Okay, so what do you mean by bad code?
Bytecode means Java bytecode.
What's Java bytecode? You mean just like poorly written
bytecode?
Yeah, Java bytecode. Sorry.
Bytecode. Bytecodes.
Yeah.
Oh God. Okay, fine.
Oh, sorry. So bytecode. I mean, the reason you can do that because bytecodes has been verified. So there's no some kind of syntactic error for those kind of bytecode, right? So, but if I do the similar things for C++, so
yeah,
you know,
your syntax checker on your C++ front end does syntax checking. Had better be correct before it emits to the back end.
Yes, so let's say that I run into some kind of syntax error in parser, but I feel that I cannot give like a correct error message for the programmers, because I have already optimized the code a little bit.
Wait. If you're in the parser, you have everything that you will ever have to give an error message.
Okay.
You're in the parser. You don't yet have any of the semantic content for the back end. You're first doing semantic parsing. That is all that you ever have, any compiler ever has to deliver an error message. Once you're through parsing, you might now go do some sort of type analysis where you might also blow out. But again, you have all the information you ever would have. And the optimizer and the backend has nothing to do with removing that information.
Okay.
So now if you are simultaneously parsing and building IR graph as you go, and you discover you have an error in the language,
yes,
the IR graph may not be terribly helpful at this point, because it might be brutalized by the error that cascaded through.
Yes, but I still have a message from in the other form, right?
You still have the text from the parser.
Yes.
Now,
okay.
What I'm doing for AA is I'm building my graph as I parse, and I'm also catching all the errors as I go and putting them straight into the graph as error state nodes in the graph, if you will. And so I get to have my semantic analysis and my syntactic analysis and typing and everything else all done simultaneously, but I'll give you sort of the best possible error message, and the optimizer won't be throwing away errors, if you will.
So it sounds like it's very possible to
it's
do
totally
that.
possible.
Okay.
I'm doing it now.
Okay. Yeah.
So if you have syntax errors, the parser blows a message. It has nothing to do with building it graph IR. If I get a semantic error, like a typing error, like a null pointer that you've not handled properly or whatever, that's ensconced in the graph. And then as I carry through optimizations, I may discover it's in dead code. I don't care, and I won't report because it's in dead code, and it's fine. But if I get to the end of the graph optimizations and I still have error nodes in the graph, then I report you an error. So at the time I capture the fact that you might have an error, I capture the point and the parse point. So I have the regular program text. I just have a pointer and I have an index into the string that I'm parsing. that I use to go rebuild an error message that says, and at this point, you have a null pointer exception that I can show you. Here's how you can get to it, and so you'll die. And then you get a syntax error, and you get a compiler error, and you bail out.
Okay, I understand that.
Yeah, you get an intermediate representation in these languages. So there'll be some parsing errors that happen in the parser before you get to an intermediate. Then you get some sort of intermediate like an AST, for instance, sort of classically here. Somebody will walk that AST trying to do typing. And if they fail, they'll have an AST to report from, but somewhere in their AST nodes, they will have captured some part of the syntax in the parser. For me, I have some set of points that I'm going to complain. Hey, here, and here, these are incompatible because yada, yada, yada.
Yeah, I understand that. Yes, I understand that.
And I'm doing my middle end, my first step of my middle end while I'm still cleaning out parse errors or typing errors. The later middle end or the back ends are all cleaned out now. But the first part of the middle end is also doing typing.
Bye-bye.
All right, everyone's got to go. We've been an hour and a half.
Thank you, Cliff.
Yeah, no problem. It's fun. Okay, next week. Bye.
Bye-bye.
See you.
Bye.